Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is going to be, I'm starting another video where I'm going to go over the C language. So I've done some kind of brief overview-ish type ones before, but this one's going to be a little bit more in depth because I'm going to spend some more time learning it more in depth myself because I just think it would be a good skill worth having. I've learned a little bit of C++ in the past, but really like JavaScript, Ruby, Python is kind of really where I've developed a much stronger set of programming skills. And I figured, and I've dabbled in Rust and Go and feel comfortable in those. So I figured, okay, it's time to just go back and do C and C++ in a much deeper way because the C programming language is much closer. Basically, you have machine language, which is like all the binary zeros and ones that a computer is actually communicating in. That's literally how a computer communicates. It's just a bunch of zeros and ones, a bunch of true and falses, and deciding what it's going to do as it processes procedures. Then, as a slight abstraction, you have assembly, which is still kind of complicated and hard to read to the human eye, but maybe a little bit less so than binary. And then you have C. C is sort of like the next level abstraction, as far as like next level of trying to create a language that's readable to the human eye versus writing things in like zeros and ones. And this is why like people go to like C. And C++ is really just C with classes. Literally, that was the original name of the language. So when you're dealing with C and C++, you're dealing with sort of a higher level API than dealing with assembly. Now, again, let me just clear up that terminology: higher level, lower level. Basically, higher level always means less complicated. Lower level always means more complicated. So the lowest level API you can be, or the lowest level you can deal with, is binary, and the highest levels are like JavaScript, Python, Ruby, where you're dealing with like interpreted languages that are really kind of abstractions on top of things like C++ and Java. Okay, so basically you have C++, which is an abstraction over, or C, which is an abstraction over assembly. And I was just listening to some history about it. It was actually derived from a language that was called B. There was this language called B. Someone saw there was some better ways to do things, so they changed it, and you have C. And then someone said, hey, C would be cool with object-oriented programming. It currently doesn't have classes, it just uses structs instead. What if I made a version of C that has classes, and you had C with classes, which later got renamed C++. Okay, so just to give you a little context of the history of it all. There is a language called D that I haven't tried yet, and I'm not sure quite how that relates to the whole history of things, but just to put that all out there. Okay, but I mean, the C is a compiled language. Now, what does that mean? It means that in order to run a program, you can't just like say, like in Node, when I'm using JavaScript, I just type in like Node, the file name, and it just runs because it's being interpreted on the fly. The code is being turned into something that's readable by the machine and then run immediately afterwards. In C, it's compiled. I have to compile it to something that's machine readable first, and then I run the code. Right there, we're already going to see speed gains because the computer's not doing two things. It's not interpreting. It's not basically compiling then running. It's compiling, and then every time you run, you're just running the machine language. So compiling in itself makes things faster. But on top of it, in C, you're doing a lot more manual memory management. So essentially, all data takes up space in memory. Okay. So for example, if I wanted to have a string, and in C there is no string type. Okay, there is everything is a character, a char. Okay, which means one single character, A, B, C, or D. So a string is really an array of characters. So if I want to say char hello, so hello is the name of my variable. So in C and C++, you declare the variable with the type name as the prefix. So I'm saying I'm declaring a something of the char type called hello, and it's an array. Okay, so it's an array of characters. And I'm going to assign a value right away. Hello world. So since I'm assigning a value right away, it's immediately going to, the length of the array is going to be exactly h1 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's telling me it's 12. Okay, see 12. And if you count the letters in Hello World, it should turn out to be 11. Okay? The reason is the string has to have one more character at the end to signify that it is a string. That's kind of how in memory is going to know it's a string. So there's always like one more character just to kind of demonstrate that. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's always one more character. And just to kind of illustrate that, let me just bring this over. There we go. Oh, it's not letting me. There we go. Okay, so if I go over here to strings, this is the tutorials point documentation for C. You can see there's this character /0 at the end. So that's what that 12th character is. So basically, when the C compiler sees this in code, it knows, okay, this is the end of the string. This is where the string ends in the array. Because again, this is a lower level API. It doesn't know all these things. It's not assuming these things. The benefit is you get more flexibility. You can do things, you can bend things in ways you couldn't bend them, let's say in JavaScript or Python. Okay, so essentially, Hello World is a array of characters. Now I can't, once you declare the array, I can't expand it. I have to end every line with semicolons. Always got to remember that. You can't expand it and you can't shrink it. Okay, because everything is, you got to say this is how much memory there is. There's kind of ways to do dynamic memory allocations, but it gets complicated versus like in JavaScript, Python, Ruby, you don't have to think about it. You just say, okay, here, I'm going to add more stuff to an array. Here, once I create the array, this is a 12 item array, and that's not going to change going forward. I could have also done this. Car, hello, we'll call this hello2. I declare the array, and then I have to declare the exact number of spaces in the array, and then I can assign it. Hello2 equals, and actually I don't think this will work. Hello2 equals hello world. I think I will need some string functions to do this. Let's see what array doesn't like that. Okay, yeah, you have to use like string copy. So you can't just even just assign it once you create it. So I can create hello2, and I think I have to use like string copy is the function. And then I always forget what the arguments are. String copy. Okay, so first is the one I want to copy, so that's hello. I want to copy hello, and I want to copy hello to hello2. And since hello should have enough spots for that, that should be successful. Okay, and then let's see what these are. Okay, and then of course every language has a function. So again, this string function, and again a lot of the stuff that C does, you're gonna have to pull in third-party libraries or part of the standard library set. So for me to do string copy here, I had to include this string library, and all these libraries are set up as header files. That's what the .h means. So I'm injecting all this code at the head of my file. That's going to allow me to do things in my program. And you'll notice this in any compiled program, whether it's Kotlin, whether it's Java. Java's a little weird. Whether it is Go, Rust, you'll always notice there's a main function. That's just a compiler convention. The idea is that the compiler, when it compiles your code, it's going to treat your program as that function. So literally when you execute the program, what you're technically doing is you're executing this main function. Okay? So what does your program do when you run it? It executes this main function, and all other code outside of the main function is just to define things that will be used in the main function. Okay? So if you think about it that way, it becomes a lot clearer, like sort of how your program behaves. Your code is compiled, and essentially your program is just an invocation of one giant function. Okay? Cool. String copy hello hello2. Now let's actually print this to the screen. So the print command in C, which comes out of this here standard input output, printf, and the way this works is I create a string. So I'll say, hey, my variables are, well, I'll say hello is, then you have to, for interpolation, you have to put like %s for a string. So that means I'm going to put a string here. But then I want that to break to the new line, so I'm going to put a new line character. Okay, and then as a second argument, then I pass the variable I want to fill in that %s. Put a semicolon at the end of that command. And I'll just do the same thing with hello2. And there we go. We have like a little mini program. Okay, and then here's like the command I would run it. So you're going to be using the, I forget what's like the generic C compiler or something like that, or the GNU C compiler, so GCC. So always just double check, do you have GCC? You probably already have it installed, because kind of most computers and most operating systems need it, but never hurts to check. So GCC-version. Okay, so I get this. So see, I have GCC. It's not the only C++ compiler. That's one of the things about C and C++ is that they have several implementations. This is why there's not really like a standard package management system for C and C++, because depending on where you're using C, you might have different ways of managing your libraries and compiling it and whatnot. Cool. So the first command I'm going to run is gcc-o, which means output. Okay, I'm going to output my program into a file called strings. Okay, and the output should come from a file called strings.c. Okay, so it's going to compile the contents of strings.c into a file called strings, and that's what this output flag is saying. Saying this, the thing right after this is the name of the output file. Okay, so I hit enter. Oh, I'm in the wrong folder. CD exercises. Let's try that again. Okay, so this time it compiled it. And then what I want to do is run the file. So I'm on Ubuntu, so it's just like /string. So if it was like Windows, it would be like strings.execute, /strings. And there we go. So we see hello is, I'm not sure where I got that out of, but you guys see the idea. Like hello is, oh no, wait, the question mark U. That didn't interpolate the way I expected it to. Why? Hello world. Maybe I think I might have this backwards then. Hello to hello. But see, now I have to recompile the code. Then I have to rerun the code. So it's 2 steps, and yeah, I had it backwards. So hello is hello world. Hello is hello world. Okay, and just to kind of recap, here I declare a character array to hold hello world, and I don't have to specify how many steps are in there because I'm initializing it right away. So it immediately assigns the number of spaces in this array based on what I assigned to it. Here I am specifying the size of the array, and it's just blank for now. Problem is, I need to put stuff in the array, and for me to do so, I have to use the string copy function to copy the string inside hello into the hello2 variable. Then I'm able to print to the screen using printf, and I'm saying, okay, hey, where this %s is, inject hello. Where this %s is, inject hello. Okay. So far not so bad. Like if you've used other programming languages, this doesn't seem horrendously more complicated. This is kind of more work, but so far not so bad. Okay, you can see this is, you can see like this is like this, because C has lasted a long, it's been around for a while, I think since like the 80s. So when you think of like modern languages and the level of abstraction and tooling they give you, this is pretty amazing to think that they have this in the 80s. So this is pretty cool. My name is Alex Merced. This is just kind of an introductory one. As I learn more things about C, I'll do more videos, but this is sort of my introductory video. So again, basically, how do you create a C file? It's just a file named C. You can include any libraries like so. These are called preprocessor commands. So essentially what's happening is that when you do the compilation, the compiler looks for these little like hash commands and runs these before it actually compiles. So really it's not reading this include is not an actual like programming command. What it's doing is that technically what the C compiler is doing is that it sees these preprocessor commands, and before it compiles the code, it's going to inject the code from this file in this spot. And then once all the code is in one big giant file, it then compiles the code. So anytime you see like anything with like a hash in front of it like this, these are things that the compiler is doing before it compiles the code. So I'm saying inject the code from this file, inject the code from this file before you compile the code. Okay, I'll leave it at that, and I think that's pretty much the same between C and C++. The difference is just like different studio names, and like in C++ you're using cout, like character out, character in, but we'll keep going along this way. Although this is probably more similar to things like Rust and Go than probably some of the early stages of C++ is. So yeah, you know, yeah, I'll leave it at that. I'll see you guys later on. Okay, make sure to go sign up for the Slack and Discord channel over there at devnursery.com, and I'll see you guys later.